Example number 2. Find the GCF of 16x squared, 4x to the fourth, and 28x cubed. Compared to example number 1, this time we're going to get the GCF involving three expressions. 1, 2, 3. And also this time, our expressions are composed of a number like 16, which we call as a numerical coefficient, together with the variable. But just like example number 1, the way we would get the GCF of these expressions is to first rewrite these expressions as a product of prime factors. Starting with 16x squared, we make use again of the factor tree method. So 16, we decompose it into its factors, and one pair of factors for 16 would be 4 and 4. 4 times 4. We further decompose these numbers because they are not yet prime numbers. 4 can be decomposed as 2 times 2, and this 4 is also 2 times 2. We then stop decomposing the numbers because now these are all prime numbers. Therefore, 16 can be expressed as 2 times 2 times 2 times 2. X squared, using the factor tree method, can also be decomposed as x times x. Therefore, the prime factorization form of 16x squared is going to be 2 times 2 times 2 times 2, and then times x times x. This time now, let's work with 4x to the fourth. So again, start with 4. Decompose that into the factors 2 times 2. And that's it. You stop because these are already prime numbers. And then x to the fourth can be decomposed as x times x times x times x. Therefore, the prime factorization form of 4x to the fourth is 2 times 2 times x times x times x times x. For 28x cubed, we start again with 28 and use the factor tree method for that. X cubed, we also decompose that as x times x times x. So that should give us the prime factorization form of 28x cubed, which is 2 times 2 times 7, and then 3 x's. Now that we have identified the prime factorization form of these expressions, we then identify what are the factors that are common to all three expressions. That means, for the expression 16x squared, 4x to the fourth, and 28x cubed, notice that all of them would contain this factor of 2. So we say that this 2 is a factor common to all three expressions. In the same way, this factor of 2 is also present in the prime factorization form of the given expressions. So that's also a common expression. This x is also a common expression or a common factor, as well as this x. So, if you look at this x here, this is not a common factor because although it's present here in 4x to the fourth, it doesn't have any corresponding factor here in 16x squared. So, we say that this x here, this is not a common factor. And it's not one of the factors which we are going to use for finding the GCF. So now that we have identified the common factors, we bring them down to get the GCF. So that means the common factor 2 for this 2 here. This 2 here, we bring that down. That's going to be part of the GCF. This common factor of x here it's also common, so we bring that down. And we're also going to make use of this common factor of x, so we also bring that down. Multiplying all of these expressions, or all of these factors, will give us the GCF, which is equal to 2 times 2, that's 4, x times x, that's equal to x squared. Therefore, the GCF of 16x squared, 4x to the fourth, and 28x cubed, it's going to be 4x cubed, or 4x squared. So again, the GCF is 4x squared. This is our GCF. This time, try things on your own. Answer exercise 1.2 in Schoology.